Hello everyone. So today we will be solving this distinct numbers problem from CSES. So the problem states that it has given a list of numbers and we have to calculate the number of distinct values in that list. So for example, it has given us five numbers and like 2, 3, 2, 2, 3, and we have to compute the distinct values, number of distinct values that are like 2 and 3. So it's a pretty easy problem. So just one thing to remember, like what data structure you are choosing. So I guess that will be kind of tricky here. So in any programming languages, we have like sets and hash tables. Okay. Now for sets, they like both stores unique values. Unique values. Now, the difference between these two are like sets are basically are implementation of BSTs. So, if you guys are not aware of BSTs, BSTs are like binary search trees. Okay. This is like set, and hash tables are like they are not BSTs. They are different data structure in which we initialize a very large array. Okay, and for every input that we want to insert into that hash table, we compute a hash of that value. Okay, now this hash will decide where to place the element in the array. So hash act as a index for that element. Okay, now the issue with hash tables is that let's say I have a value a, okay, and I have another value b. Now if I compute the hash of A and the hash of B, okay, so let's say they give me some index A IDX and B IDX, and based upon the hash algorithm that this data structure run, it might happen like A of IDX might become equal to B of IDX. Now uh, this is a problem with hash table because whenever we have this, so we designate them like hash collision. So whenever we have this kind of thing, then hash table linearly iterates over its cells in order to find a empty cell and it put that value. So what will happen, like let's say first I insert A. Let's say this is AIDX. Okay, A has been already inserted. Okay, now when we have B and we are trying to put B here in this data structure, so what will happen, like since AIDX is already taken by some other number, it will start to search linearly over the next cells, like whichever one is empty. Now let's assume like this cell is also occupied with some values. So it will linearly iterate and it will find the next cell which is empty and it will put the BIDX there. Okay. Now due to this, the worst time complexity for insertion in hash table becomes big O of size of the hash table. Yeah. So I have put this norm designation here, like we use mathematics, like we use in math, like whenever we are representing size of a data structure or something, we put this norm operator here. So yeah, so the worst time complexity for insertion in a hash table is big O of size of the hash table. Now the average time complexity is big O of 1. Now in some languages it might happen that, so in C++, if I take example, sets are basically BSTs and hash tables are, yeah, this data structure. But in languages like Python, both are hash data structures. So this nuances like will help us to choose the better data structure or programming language in order to solve this problem. So yeah, so now I can directly jump to the code. So instead of hash table, I will be using BST. Now for BSTs, what happens is that since this is a tree, so it will store something like this. Okay. Now the BST definition is like we will start with the root. Okay. Now on the left, we will be storing the values that are smaller than this node, and on the right we will be storing values which are larger than this node. So you can also read about it. There are various articles regarding BSTs and their implementation, but I will not be like telling you all that. I want you guys to explore. So yeah, now since this is a tree, so it will happen like, let's say I have n numbers. Okay. Now, when I'm inserting those n numbers in this tree, so it might happen like I have to put a node or I have to create another node itself. Let's say I have to create this node in order to put some value, let's say A. Okay. Now, if you see like the traversal will happen. So the traversal time complexity will basically results in my insertion time complexity. Now, so what will be the traversal time complexity? That will be nothing other than the height of the tree. So I may start from here, I will jump from here, then here. Since in BST we traversal by comparison, like hey, whether I have to put on the right subtree, hey, whether I have to put it on the left subtree, like that I have to move, and with that I will be like neglecting all this nodes, and I will have a particular direction like where to put that value. Now, even with that direction, I might have to traverse all the way to the down, like, or to create another node in the tree itself. Now, for that, I will be traversing the height of the tree. Now, as we know, like the tree properties, the height of the tree is nothing other than log of n. So yeah, so the insertion time complexity in BST is log of n operation, whereas in hash table, due to hash collisions, the worst time complexity is big of hash table size. So yeah, so I'll be coding in C++. So and I will be using set, or I can say a BST. Cool. Uh, so let's first take the input. So this is n. Okay. Now, after that, we have been given this list of numbers, and for that, I can run a for loop. I plus plus, then let's say temp, and let's declare our BST here. Let's call it finder, and I will be taking the value here, and I will be inserting the temp here. And the number of distinct values will be my size of this set. Cool. So I have already taken this input here. I can run the cell. Cool. So 2 it is. Let's submit our code. Nice, all got accepted. So here we can say like the time complex. Let's do a time complexity analysis. So the total time complexity will be the number of elements I will be given, and times for each element. So let's say I have been given n elements, and for each element I will be doing a log n operation. Now in the input it might happen like all the elements are same. In that case, I'm quite lucky, so I don't need to insert all the values into the BST. But if all the values are distinct, then this will be my worst case time complexity. Now for space complexity, yeah, same. So if all the values are distinct, so my BST will be populated with all the distinct values, and let's say there are total n values. So that space complexity will be big O of n. Cool. So I hope you guys learned something new. So just stay tuned to watch more videos on it. Cool. Thanks.